Hello everyone, my name is Khaled and this is my longer version of the video. For my project I've chosen to do a case study on the Internet of Things, and I have decided that the focus of my study will be the size of the Internet of Things. So just a quick introduction to what is the Internet of Things. So this is a relatively new term, and what it really means is a very large network, something like even bigger than the internet, and obviously it does include the internet, but it contains the main feature really isn't about size, it's about what it contains. So the Internet of Things should contain things. So it's devices or machines communicating to each other without any human interaction. So you can think of some of the types of devices are vehicles, robots, wearables, sensors. Like for example, you can have sensors on the roads, and when your smart car is driving on that road, and the sensors can see that it's been snowing and it's quite slippery, then that sensor could instantly communicate to your car, to your smart car, to tell it to slow down because it's slippery. So that's a very quick example. Um, so why is the Internet of Things important? Well, as you can see, it's a good question. Um, so the Internet of Things is very important because it basically enlightens you. It gives you more awareness. So what it does really is it gives you more information. And as we all know, knowledge is power. So the more information you have, the more power you do have. Um, let's see, from that diagram, you could see here that everything on this image is telling you something. So something is telling you, pick me up, take me, so that's medicine when you're sick, drink me when you're dehydrated, fix me when something is broken. So it's that kind of information that makes you more aware. So instead of going home and suddenly finding out that your TV is broken, that's not a very good situation. But if your TV has some kind of way to communicate that it's about to break, then you would know that you need to arrange to fix it before it actually breaks down completely. So that's the sort of thing that the Internet of Things will be introducing. Um, so what kind of applications can we expect? So a lot really. On this slide, I give you three examples, which I picked up from a website which you should see the link down here, see more. So one example is smarter natural disaster management. So what does that mean? That means that if you have the right sensors in the right places, and you know that, for example, the forest is quite fragile, and you have lots of um, trees burning every year, then you could really manage that natural disaster much better when you know it's coming, and you could even avoid it because you can see the symptoms before the forest actually start, and then people would evacuate from that area, and it would be a much better situation. Something else is smarter urban management, and what that really means is effectively governing the traffic in a smarter way. So obviously, depending on the area and the time of the day, and not even the time of the day, even after a few years, sometimes we have areas which are quite empty, and then suddenly the hype goes up, and a lot of people start moving there, and then it gets quite crowded. So the conditions are always changing, always changing. And what's smart about the Internet of Things is that it's continuous. So you always have the right sensors in the right places, which monitors the traffic and would see the trends, and it would then divert the traffic to other roads or do whatever smart decisions it thinks. But the main idea here is that it learns, it learns in an ever-changing condition. Also, same thing applies to parking. Yeah, I'm sure we all suffer with parking. Something else is smarter healthcare. So most of us have seen by now the wearables, the Fitbits and Joe Bones and stuff like that. But imagine if those things were not just to like they could get a lot more sophisticated, and they could maybe not only measure how many steps you've done or calories you've burned, but they could also see your heart rate, your blood pressure, your um, stuff like that, more medical stuff. And when that happens, when your simple wearables are quite aware of your health condition, then obviously it communicates that to your healthcare provider, or obviously depending on what settings you put in, or your own mobile device. But the idea here is that you would then be able to um, basically avoid going into bad situations. Um, so the focus of the study, as I mentioned before, is the size of the Internet of Things. So what I've done is I wanted to see how big is the Internet of Things. It's growing fast, we know that, but how fast and how big is it? Is it now? How big is it going to be in 2025? I've seen some estimates on the internet which estimate how big it's going to be up until 2050. So what I'm doing here is I'm not trying to estimate the size, because that study has been already done. It's all over the internet. What I'm trying to do is to divide to combine that. So I combined this data source with two other data sources. One is which the mobile devices, how many mobile devices we have, and that is quite like the Internet of Things. That's speculation, right? No one knows how many robots we'll have in the future, but how many mobile devices we have now, that's quite easy. Like all the mobile carriers know exactly how many devices we use. So that's a reliable data source. So I've taken that, and obviously that's directly linked with the population. So human population, when you have more people, you have more mobile devices being sold. So that there is a direct link, and I use that link to measure how the Internet of Things is going to look like in a few years from now. So in terms of technology, I've decided to use R. Advantages of R: it's very easy to install, very easy to learn. Special functions are quite well documented on the internet, so you can always find what you need. Capable of generating decent graphics and visualizations. The disadvantages are that basically the charts are not as pretty as they could be. Maybe if I used D3 it would have been prettier, but then I've decided I wanted to improve my R skills, so I decided to do the whole thing in R. Also, I struggled a little bit when trying to use something like a pie chart. Then your data set has to look in a certain way, so that I didn't like. Maybe it's because of my lack of experience, but that's something I faced. So to show you my data, the raw data was basically this is an Excel file that I pulled off the UN website, and it has all the like the population of the world, every single country, and some aggregations as well, from 1950 up until 2016. That's the first one. The second one is something that was scattered all around the internet, but I found a web page on Wikipedia which basically gets all the data together. So you have it tells you that in China they use this amount of mobile devices, in India this amount, in the US, Brazil, and so on and so forth. So this data set is I think 70 something countries. So what I've done is I subsetted the other data source, which is the UN population thing, into the same amount of countries. So my focus is now these countries, because these are the only countries I have credible information about how many mobile devices they use. And then obviously this is the estimation of the Internet of Things. As you can see, different websites estimate things differently. I've chosen to obviously eliminate all the duplicates, and I've chosen to take the numbers that made more sense to me. So I chose basically the higher numbers, um, and because sometimes it doesn't make sense that you have less connected devices than you have mobile devices. Obviously, it doesn't make sense. So I've chosen the numbers that made sense to me. Um, so first thing is you need to clean up the data. So you go around. For example, here I had some null values which I removed initially, and then you have here one data source calls Russia, another data source calls it Russian Federation. So obviously, when you do a lookup to combine the two data together, it doesn't really work. So you have to take care of that as well. Next, I loaded this data into R. So using read.csv, it was quite easy. So obviously, after combining the data, I had to save it as a CSV, and it was comma delimited. So and then you load this into R, and then once you have the data into R, I had country column, and I had columns for the population from 2012 all the way to 2025, and I had the same for mobile devices and the same for Internet of Things, and divided by country, obviously. And we have one record here which says world, which is the total of everything. Once this is done, I can quickly show you how it looks like in R. I'm not sure if this is visible on my screen, but let's see. So this is the code that I've written in R. So it's quite easy. R code is quite easy, and as you can see, you just load the data frames and my frame, sorry, and that's the main frame, and it has countries and populations, and then you scroll to the right, it has mobile devices. So for this country in 2015 they had this amount of mobile devices, and we expect it to grow to that number in 2018, and the same thing for the Internet of Things or connected devices. So that's a total of all the connected devices at this time of at this year for this country. And the way I've done that is I've basically taken the relationship between the population, the human population, and how many mobile devices we have, and I've used that relationship to like I said, I already had the total number of connected devices. Let's say in 2015, I know that we have 2 billion, for example, off the top of my head, and knowing that India, for example, accounts for 2% of all of that, then I would assume that India would be 2% of that 2 billion. Obviously, I'm just making up numbers now, but when we look deeper into the report, you would see the actual numbers. So I've deducted that information, and then I started visualizing data. So this is the population. I've also I've had to split my data into 3 categories. So large countries, smaller, like medium-sized countries, and small countries, because when you put it on a chart and you have countries like China and India, which is in the billions, and then you have very small countries, very tiny, maybe African countries or something, and their populations are hardly over 2 million or something, then it doesn't show. So I had to split it, and these are from the medium-sized countries, and you could see here the estimation. So that maybe the font is not very clear, but when you have 300 million people in a country, you have 4 billion connected devices. 4 billion. That includes personal devices and also sensors and robots and stuff. So that's massive. That's a massive difference. And then I tried to plot the correlation between the two, and you could see it's almost linear. And the reason is because obviously we've taken into account the human population, but that does make sense, because when you have more people, they buy more mobile devices, and when the future comes, and just like now, mobiles are not, you cannot get rid of your mobile. In the future, you won't be able to live without your sensors and your robots and your connected cars. So it does make sense that when the population grows, also the demand grows, and more people means more roads, means more sensors on the roads, more sensors on the bridges, and so on and so forth. So the interesting takeaway points from here is, first, we can see that the even though the world population is growing fast, but the Internet of Things is compared to that is growing exponentially. So it's massive. That difference is huge. Also, let's assume that it works and we have the Internet of Things and it works perfectly fine. That will mean that we'll have a tsunami of data, so a massive amount of data flowing around between connected devices and machine to machines. So is our infrastructure really ready for that, do we think? Do we invest enough in our infrastructure to cope with that trend? I'm not sure about that. I have a feeling that at some point we'll have a bottleneck, and every network will be so slow because we have so much data flowing around from every side of the world. Also, the data will be only as good as the sensors. So have we reached the point where the sensors are 100% accurate? Because if the sensors are not of high quality, then really what we're getting is, I don't want to say bad data, but not very accurate data. Also, one last point, only if you're a sci-fi fan, when the ratio of humans to machines reaches 1000 to 1, do you think the machines will take over? Like in the movies? And that's it, and thank you very much for listening, and you can find my full report on the website. Thank you.